Study Session 8. Diagrammatic Representation of Frequency Distribution. Introduction. Statistics involve, among others, the presentation and interpretation of data in some diagrammatic ways. This study session will discuss the representation of frequency distribution using pie charts, pictogram, and stem and leaf display. Learning outcomes. When you have studied this session, you should be able to present raw data in the form of pie charts, histogram, and stem and leaf display. The pie chart. It is a circular diagram in which classes or attributes are represented by sectors. Each sector represents a class or attribute at a proportion equal to the percentage or relative frequency of the class or interval. Each sector represents a class or attribute at a proportion equal to the percentage or relative frequency of the class or attribute. The relative frequency of an attribute is the ratio of the frequency of that attribute to the total number of occurrences of observations. Using the example of the number of employees in the various departments of a company, see Table 8.1. The steps involved in drawing a pie chart are provided after the table. 1. Find the relative frequency of percentage of the employees in each department using the formula RF equals number of employees in departments, FD, all over total number of employees in department, FD, times 100 over 1. For marketing, RF is 153 divided by 498 times 100 over 1, which is equal to 30.7%. For accounts, it is 60 over 498 times 100 over 1, which will give us 12%. For production, we have 102 divided by 498 times 100 over 1, which will give us 20.5%. For personnel, 85 over 498 times 100 over 1, which will give us 17.1%. For works, 153 over 498 times 100 over 1, which will give us 12%. 2. Calculate the angle of the sector for each department using the formula angle of sector equals FD over summation FD times 360 degrees over 1. For marketing, we have 153 divided by 498 times 360 over 1, which equals 110.60 degrees. Accounts, 60 over 498 times 360 over 1, which will give us 43.37%, which will give us 43.37 degrees. For production, 102 divided by 498 times 360 degrees over 1. That will give us 73.74 degrees. For personnel, 85 all over 498 times 360 degrees over 1. That will give us 61.45 degrees. For works, it is 98 over 498 times 360 degrees. That will give us 70.84 degrees. 3. Draw the pie chart. This can be done neatly with a pair of compasses and a protractor. Using a pair of compasses, measure any length and draw a circle showing the circumference. From the center of the circle, draw a straight line to the circumference, that is, the radius. At the radius, use your protractor to measure the various degrees calculated for each department and show the corresponding percentage in the division. The resultant diagram is a pie chart, which you can see in figure 8.1. The pictogram. The pictogram is also called the pictograph or ideograph. It is a graphic way of presenting data with emphasis on the aesthetic aspect of the display and not accuracy. The symbol or picture chosen for any set of data must have relationship or resemblance with the concept being portrayed. For example, look at figure 8.2. It shows the pictogram of death recorded in table 7.1. The stem and leaf display. This is a simple, useful but uncommon technique for summarizing a set of data by combining the features of the frequency distribution and the histogram. The class intervals form the stems, while specific values of the raw data within each interval form the leaves. An example using scores in table 6.3 and illustrated in table 8.2 is shown in table 8.4. Each leaf is made up of a number of scores falling within a given interval, while each score represented mainly by the last digit of the score. If there are 2-digit scores, the score in each leaf are then ordered from low to high. With a class interval of 23 to 27 in table 9.1, for instance, reading the raw data in table 6.3 horizontally, the scores falling in this interval are 26, 24, 23, and 27. The last digits for these are 6, 4, 3, and 7 respectively. These form the leaf for the interval 23 to 27. When ordered from low to high, the leaf stands as 3, 4, 6, and 7. Do the same for other intervals. The stem and leaf display shows the same graphic representation as the histogram because each observation takes up one space. Also, it is very easy to recall each score in the raw data from the display. For instance, it can be read from the display that the scores within class intervals 18 to 22 are 20, 22, and 19, since the leaf is made up of 0, 2, and 9. The 0 is for 20, 2 is for 22, and 9 is for 19. Remember, the interval is 18 to 22. For data with 3 or more digits, you may choose to increase correspondingly the number of digits to use for the leaves. Study session summary. In this study session, you have learned that the pie chart is a circular diagram in which classes or attributes are represented by sectors. A pictogram is a graphic way of presenting data with emphasis on the aesthetic aspect of the display and not accuracy. The stem and leaf display is a technique for summarizing a set of data by combining the features of the frequency distribution and the histogram. End of study session. Thank you for listening.